Lesson 3-6, Compound Inequalities. All right, so this lesson is kind of jam-packed with a ton of new information and examples. So it's really important that you take really good notes and remember that when we come back to class, we will always go over all of these things along with much more practice. Okay? So we know what inequalities are, we know how to solve them, and we know how to graph them. Today we're learning about a compound inequality. Compound inequalities consist of two distinct inequalities joined by either the word and or. So remember with inequalities, you can have like x is greater than 4. There are a lot of solutions. I'm going to mute the sound on my computer, sorry. So x could be anything bigger than 4. With a compound inequality, x could be bigger than 4, or it could also be less than -3. There's two different solution sets. So we're going to talk about these two, and versus or. So in an and compound, say we have the inequality x is greater than or equal to 3, which goes this way on the graph, and x is also less than or equal to 7, which goes this way on the number line. Notice they have a common middle. So I would graph it like this on my number line. This is where x can be that satisfies both of those inequalities. In an or compound, your graphs are not going to touch. They don't have any common space. So like x is less than -2 goes this way, x is greater than 1 goes that way. Notice they don't touch at all, so you would graph it like that. They go in two directions. Now with and compounds, you can write them two ways. I'm going to extend the page. If I have x is greater than or equal to 3 and x is less than or equal to 7, I could also write that with x in the middle. X is less than or equal to 7, but it's also greater than or equal to 3. So you can write it either way, but we can combine an and inequality. Ors, you cannot. They're written as two separate inequalities with the word or in the middle. Okay, so first let's try to write compound inequalities. So in example A, we want to write a compound inequality for all real numbers, so that would be our variable x, that are greater than -2 and less than 6. So I see the word and, so this is an and compound. I'm going to put x in the middle then, because we can do that with these ones. So all numbers that are greater than -2, so the greater, it's opened to the x, so it's x is greater, and less than 6. Okay, so that's how I could graph that first one. If I wanted to, write it. If I want to graph it, it's an open circle at -2 and an open circle at 6, and then I just combine my graphs like this. Okay, how about part B? All real numbers that are less than 0 or greater than or equal to 5. So this is an or, so I'm going to have two separate inequalities. All real numbers that are less than 0 or greater than or equal to 5. So it's okay that some will be an open circle like this one, and this one's going to be a filled in circle at 5. This arrow is going this way, and this arrow is going that way. So they're not going to touch. All right. Now, part 2, solving a compound inequality involving the word and. There are two ways to do this. I will show you both ways. All right, so here is our compound inequality. It is not yet solved. So the first way you can do it is you can write it as two inequalities. So m minus 4 is kind of our common ground. M minus 4 is greater than -3. I'm just going to split this up, greater than or equal to. I can also use my middle ground, m minus 4, and the other half, less than -1. So I just used my middle piece in both parts and then rewrote them as two separate inequalities. Okay, so it's kind of a lot of ink. I'll do that one more time. So -3 is less than or equal to m minus 4, and m minus 4 is less than -1. So now I can just solve these two just like multi-step inequalities. I'm going to add 4 on both sides over here. So I have 3. Oh, I'm sorry. Eraser. -3. Oh, wow, that was big. Negative 3 is less than or equal to m minus 4. I'm adding 4, adding 4. 1 is less than or equal to m, and add 4 to both sides. M is less than 3. So there's my two inequalities. I could also write this as a compound like this. And then I'm going to show you how to graph two. I'm kind of running out of room. I'll do it down here. So I can make my number line. I have my number 1 and 3 filled in circle, open circle, and their common ground because m's greater and less. So there's my graph. So the first method is separating the two inequalities. The second method, I'll do down here, we can actually do it all at the same time. So I'm going to copy this down again. I can work from the middle, so I'm going to add 4, but I have to do it to both the right and to the left sides. So negative 3 plus 4 is 1. Negative 4 cancels. I have my m. And negative 1 plus 4 is 3. So I have my inequality, and I can graph it the same way with my 1 and my 3. Oh, this should have been a closed circle. This is an open circle, and sharing. This should have been an open. All right. So solving an and compound. Remember, if this was another example, I could make them two separate inequalities, or I could work from the middle, add 4 to both sides. I'd get 2 is less than 3y, which is less than 18, and then divide by 3 to all the parts as well. So 2/3 is less than y, which is less than 6. There's my answer. All right. Now we're going to write and solve our own compound inequality. It's important to know how to do this. All right, so you're going to see problems like this a lot in our book with this lesson. To earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. The word inclusive, this is good to know, means greater than or less than or equal to symbols. So inclusive means it includes that point. Exclusive would be these symbols. So like x is greater than 4, that's exclusive because it doesn't include 4. This is inclusive because it does. Okay, so test scores between 84 and 86 inclusive. You scored an 86, 85, and 80 on the first 3 tests. What possible scores can you earn on the fourth and final test to earn a B in the course? So we need to set up a compound inequality. This is going to be an and. So we're going to start by, on the outsides, putting what we need on the outsides to get our B that we would like. So inclusive means whatever we score on these tests, we want to be greater than or equal to an 84 or less than or equal to an 86. So we've already taken 3 tests. We've gotten 84, 86. Oh, I'm reading the wrong numbers. I need these ones right here. 86 plus 85 plus 80, and we're going to take one more test, so I'm adding another one, and we want the average, so I'm going to divide that by 4, because eventually there will be 4 tests taken. So now I'm just going to solve this compound inequality to see what our fourth and final test score should be to fall between these averages. All right, so to get rid of the divide by 4, I'm going to times this whole middle by 4, the outside by 4, the other outside by 4. So my 4's in here will cancel. I'm left with 86 plus 85 plus 80 plus x, which is less than or equal to 336, or sorry, greater than or equal to, and less than or equal to 344. Now combine like terms, 86, 85, and 80 combined is 251. So I'm going to subtract 251 from both the middle and outsides. When I do that, I have 85 is less than or equal to x, which is less than or equal to 93. So I would need to score between or including 85 and a 93 to be able to make this grade that I want. So go back and watch that example if that didn't make sense to you. I believe a problem like this is in your lesson check. Okay, moving on. How do we solve a compound inequality involving an OR statement? These ones we can't do at the same time, so you just solve them as two separate inequalities. So 3t plus 2 is less than negative 7. I'm going to subtract 2 from both sides of the inequality. I have 3t less than negative 9. Divide by 3. Remember, if you were dividing by a negative number, you'd have to change your inequality symbol. I have t is less than a negative 3, or negative 4t plus 5 less than 1. I'm going to subtract 5 from both sides. So I have negative 4t is less than negative 4. Divide by a negative 4. Oh, here's where we're dividing by a negative. So I have t greater than 1. So my answer is t is less than negative 3 or t is greater than 1. Now, to graph that, I'm going to use this graph right here. Oops. Negative 3 with an open circle. T is less than that. 1 with an open circle. T is greater than that. So remember, an OR should always have graphs in two different directions. So had we forgotten to flip that sign, we would have noticed something wrong in our graph. All right. Finally, this last part of our lesson is talking about interval notation. We can use this to describe an interval on the number line. It includes three special symbols. Parentheses. We use parentheses when we're talking about a less than or greater than symbol. So the endpoints of our graph are not included, so parentheses. When they are included, we use brackets. So those are for our less than or equal to or greater than or equal to symbols. The endpoints are included. And when a graph arrow goes on forever, we use an infinity sign, which is that sideways 8. So let me show you what I mean. Here's the inequality x is greater than or equal to 2. It's easier to write interval notation for our solution set. That's what we're making it for, all the solutions, when we look at a graph. So here's just a simple inequality. X is greater than or equal to 2. So all my solutions start at 2 here, and they go this way. So 2 is included, so I'm going to use a bracket, the number 2, comma, and since it goes forever in this direction, I'm going to use an infinity sign. And since we can't define when that ever ends, we just close it with a parentheses. Okay? And the next one I'll do over here. X is less than 2. So you always work left to right like you're reading. So we're starting over here. Well, that's a parentheses because we don't know a definite point. And, since it's a negative infinity, since it goes to the left, you write negative infinity. I'm going to erase this mark here. Comma. And it ends right here at 2, but there's an open circle, so I want parentheses. If it was filled in, I would use a bracket. All right, here's a compound example. 1 is less than x, which is less than or equal to 5. So here's my interval right here. Starting on the left, I have an open circle at 1. So parentheses, because it's not included, and it ends at 5 with a filled in circle, so that would be a bracket. And here's an OR compound. So I have two intervals to write. I'm going to use the word OR in the middle. So first, this interval, from left to right, I have a negative infinity, because it goes forever left, and it ends at, looks like negative 3 with an open circle. And then my next interval is 4, bracket, because it's included, to positive infinity with a parentheses, since it goes forever to the right. So these are using interval notations to mark a solution set. So in our final example, what is the graph of negative 4, 6 with that interval notation, and how do we write it as an inequality? So I think the graph is easier. Negative 4, and it's a bracket, so it must be filled in, and 6 with the parentheses, so it must be open. So it must be a AND compound. That's the graph. So if I write an inequality, x is in the middle. It's less than or equal to negative 4 because of that bracket, and it is just less than 6. So we'll practice with that more back in class. I'm going to bring us to our lesson check. Try your best on 1 through 4. I want to see your attempt, and I really want to see your notes.